You can invoke a full cluster repair via Node Tool. However, performing a full repair often bogs down the node and can also hurt cluster performance. Other nodes must verify their replicas with the node you are repairing with. Depending on how out of sync your data is, this also places extra load upon your network as well. As an administrator, you must also be sure to run a full repair within GC grace seconds to prevent zombie data. This is a pain to manage. DataStax Enterprise 6 has a new feature called Node Sync. In short, it continually runs in the background checking for out-of-date replicas and syncs them with the most up-to-date version. This is better than a full repair as it causes a trickle of load on your cluster rather than weighing it down with a full, occasional repair. This feature is automatically enabled in DataStax Enterprise, but you must enable it on a per-table basis. All nodes run Node Sync in the background, checking up on each other's replicas and ensure that they are in sync. You can see how we enable Node Sync in the Create Table statement here. For those of you who are curious, here are some details about how Node Sync works. Node Sync divides its nodes' local token ranges into segments. Node Sync repairs these segments as a group. It also tracks the results such as success or failure, saving its progress as it moves along. Each time Node Sync completes a repair on a segment, it records its progress in a data structure we call a save point. Remember GC grace seconds? This is 10 days by default. Node Sync prioritizes segment repairs so that each segment is repaired within this grace period, taking the worry of repairing the entire cluster away from you. Node Sync aims for segment sizes of about 200 megabytes. You can configure this if you like, but 200 megabytes is a good default. If a partition within that segment is larger than 200 megabytes, then the segment size grows to the full size of that single partition. To determine which tokens make a single segment, Node Sync first starts with the entire token range segment and then recursively splits it until the target size is found. But instead assumes a decent data model with a good distribution of data. Node Sync considers segment repairs as an atomic unit. That is, the entire segment must succeed in repairing as a whole in order to mark the segment as complete. Node Sync records the status of each segment repair in the Node Sync status table. If the node fails during a segment repair, Node Sync considers the segment unrepaired as a safety mechanism. Node Sync records the status of each segment repair in the Node Sync status table. Here are the possible results of a segment repair. You can see the most successful result at the top, followed by less successful results as you progress down this list. Full in sync means it checked all replicas and they were already in sync. Full repaired means all replicas responded and some repair was necessary. Partial in sync means that some replicas responded and those that responded were already in sync. Partial repaired means some replicas responded and some repair was necessary. Uncompleted means only one replica was available, so no syncing was possible. Failed means the sync simply failed, and you can find more information inside of the logs. Repairing a segment is straightforward. Node Sync uses the same repair process that read repair or full repair uses in their repair process. That is, read the data from all replicas and ensure they are in sync. If they are not in sync, update the nodes with the earliest timestamps to the nodes that have the latest data.